Hey scholars, welcome back to Math Savvy. We're ready to dive into more complex numbers. We are multiplying and dividing today. We are taking it one step further. We're going to kind of talk about like the algebra of complex numbers, and we're getting used to the vibes here, right? They're an acquired vibe. Okay. Anyways, when I say multiplying and dividing, it's really kind of like a simplifying an expression type of problem with a complex number. If I is the square root of -1, let's figure out what this is. Let's figure this out, okay? What can we do? We take the square root of -16. A rule is that we can factor a square root as long as we keep that square root. So I'm going to do 16 and 1 square root times -1. That -1 is the same as I, so I get root 16i. And what is the square root of 16, you guys? What is it? It's 4, duh. So boom, that's kind of the idea here. Instead of something looking like this in the math world, we want something that looks like that. Okay, what do we do if we multiply I, right, by itself? I squared is going to be the square root of -1 squared. When you square a square root, you're just going to get whatever's inside the square root. So I squared is -1. That's just like a known fact, and you should know that on the top of your brain right here. So then when we get to I cubed is I squared times I. I squared is -1 times I is just going to be -I. Okay? Something else you should know. I to the fourth is I squared times I squared, which is -1 times -1, which is 1. Okay, I to the fourth is 1. Isn't that cool? So then we use this cycle again. I to the fifth is I. This is the cycle. So once you get to 1, you go all the way back down to I. And then you go I to the sixth, because you would do I fifth times I, you would get I squared, which is -1. I to the seventh is -I, so you see this pattern here. This cyclical, type of group here. Goes on forever. Okay, now let's get into multiplying and dividing. If you remember FOIL from 5th grade, I don't know, you tell me, bro. We're gonna do that. So we do first, outer, inner, last. So excuse my appearance, I'm sick right now, but I guess there's another way that they're teaching this these days. So I just wanted to go over the other way before I, continue with my method, which is obviously the better method. So you put this and this on the top, and then you put this and this on the side where the rows are. And then you would multiply these here, and then these here, and so on and so forth. So this is going to be 1. This is going to be I. This is going to be 2I. This is going to be 2I squared. And then you would put them all together. Here, 1 plus I plus 2I plus 2I squared. So I guess that's like another way that we could do this, which you can do that, but like, whatever. Anyways, bye. So 1 times 1, that's going to be 1. And then we do outer. So we do 1 times 2I, which is 2I. So we're doing this so far. Got it? I times 1 is going to be plus I. I times 2I is going to be plus 2I squared. Combine like terms, so we get 1 plus 3I plus 2I squared. Now, as math teachers, we do not want to see an I squared ever, because we want to simplify that. We know that I squared is -1. So our final answer here is going to be 1 plus 3I, and then that I squared is going to be a -1. Okay, so we got 2 times minus 1. 5 times 5. We got 25. 5 times negative 3i, that's going to be minus 15i. 3i times 5i, that's going to be 15i. And then plus 3i times minus 3i is going to be minus 9i squared. So let's combine these like terms. These are just going to cancel each other out, right? And then we just get minus 9i squared. And then we get 25 plus 9. This 9i squared is going to be equal to minus 9 times minus 1. That equals 9. Okay? And then, of course, we can combine those real numbers to get 34. Okay? So I put this problem here to illustrate that this, in complex numbers, the same goes for difference of squares. So this plus and this minus, we can just see that as a shortcut of getting rid of these. And so we would just do 5 squared minus 3i squared, because that's just the t, right? Let's distribute. So we get 4i times 3, which is going to be 12i. We get 4i minus times minus 5i. So we get minus 20i squared, of course. Simplifying that, we get 12i plus 20. And that's the t. All right, now we're dividing. We're simplifying. We're doing our thing, right? You can never have an I in the denominator. That's just like not allowed, right? So what do? We multiply by the conjugate. We do 1 minus I. We just change the sign there. We change the plus to a minus, and we have the same real and complex part, right? And of course, what we do on the bottom, we must do on the top. So, boom. Let's do the top first. 1 times 1 is 1. 1 times minus I is going to be minus I. Easy, right? These are differences of squares. So I already know that this is going to get rid of the I. So what do? We do 1 times 1. And then we know that this I times 1 minus I times 1 is going to cancel each other out. So we just do plus I times minus I, which is going to be minus I squared. That is the same as 1 minus I over that minus I squared is going to be negative 1. So it's going to be 2. So that's our final answer here. That's the same thing as this. That's simplifying, because this is not considered simplified. Try this on your own right now. Figure out the conjugate, get rid of the bottom I, and let's reconvene in a second. So what do? We get minus 2 plus I. What we do on the bottom, we do on the top. So 4 times minus 2 is going to be minus 8. We have 2i times minus 2, which is going to be minus 4i. We have 4 times I, so I get plus 4i. And then we get plus 2i times I, which is plus 2i squared. Okay. Right away, I can notice that these will cancel out. And then also what I notice is that this I squared, so I'm just going to fix that right away. This is going to turn into a minus 2. Okay, so then we do the bottom. Minus 2 times minus 2 is going to be 4. We already know that these are going to cancel out because we strategically multiplied it by the conjugate. We multiply the complex part, so we get minus I times I, which is going to be minus I squared. What do we get? We get minus 8 minus 2, which is going to be minus 10. 4 minus I squared, which is 4 minus minus 1, which is going to be 4 plus 1, which is 5. That is going to be minus 2. And that's all. Let's do a trick question. Before we go on, we are going to get rid of all of these crazy i's, and we're just going to simplify them. So I cubed is the same as negative I. So I'm going to take that I, I'm going to take out that negative. So then this I squared is going to be minus 1. So let's put that in the problem. I to the 5th is going to be the same as I. I squared is minus 1. So this is going to be plus. Okay? So 24i minus 24i. Distributing that negative, we get plus 1. And then on the bottom, we just get I plus 4. We see here that these 24i's will cancel each other out, of course. So then we get 1 over I plus 4. As we all know, we can never have an I in the denominator. The top, multiplying anything by 1, you're just going to get the same thing. And then we get I squared. These will cancel out, and we get 4 times negative 4, which is going to be minus 16. Okay, and then we are going to turn that I squared into a real number, because that is what it is. So this is going to be I minus 4 all over minus 1 minus 16. Finally, we get I minus 4 over minus 17. Okay, we did it. We did it all. Thanks so much for watching. As always, hit me up for tutoring, for video requests, all of the above, right? Everything. If you even want to talk about something, like hit up our Instagram or TikTok, we'll respond, right? Peace and love.